Hello, this will be a review of the Kossel Delta 3D printer made by Anycubic. It's a Chinese company. This is the box it comes in, fairly small and compact, very well packaged. We start by opening it up. This printer has an advantage that it uses linear slide instead of the standard Kossel rollers for the motion system. Here is the package. Very well arranged and packed inside, it looks like. User manual. I'm going to shortly leaf through this so that you can see the pages and you can pause and watch the video. So here is a leaf through the user manual. I'll just go through it quickly and you can pause the video and watch. Packing list. Assembly of the bottom and top triangles. Extruder. This printer has a metal extruder, which is very good. The head itself is a type of E3D head. The linear slides and the variant with rollers, but I have bought the linear slide version. It costs about $200. Here is the assembly of the end stops here. Extruder. The extruder is entirely made of metal, which is very good. The board is fully integrated board, which is a type of Arduino Mega compatible one with ramps 1.4. Wiring of the board, X, Y, Z axis, 2 extruders. The kit comes with 5 Pololu type drivers, but only 4 are needed with A4988 stepper motor drivers. Only 4 of these are needed for this printer because it uses 3 for the axis and 1 for the extruder. The bed is a piece of glass, but I have also bought the heated bed as an option. It has a display in the kit, 2 lines, 4 lines times 20 symbols each, and then a section on the firmware setup. Which will come at the end. And that's it. The other piece of paper which was in the box. Some instructions. It has links to videos on YouTube for assembling, as well as a Google Drive directory for the firmware updates that they give. And this is a packing checklist of all the parts in the printer. That's it for now. Next, we'll look at the parts inside. Let's zoom this out a bit. And so, let's look at the parts inside. This is packed in a very nicely arranged cut-off foam. Here, stepper motors for the 3 axes, stepper motor for the extruder. The extruder motor is larger than the one for the axis, which is very good. I'll zoom in to show you this. Here is the extruder motor. And for comparison, next to it, the motor for the axis. You can see it's significantly larger. They're both NEMA 17 motors, but this one has it's deeper. Here is a close-up at the writing, if you can see it. Okay. Back to the parts in here. Cables for the stepper motors. Power supply. This power supply is not powerful enough to support a heated bed. However, you need to purchase a separate one. This is the heated bed, which was an optional part. I bought it separately, even though they have a now version of the printer which has a heated bed by default. I'll set it aside here. The top triangle, maybe we can do this so they are better visible. The top triangle and bottom triangle. These are normally 3D printed in a typical Kossel, and in fact in this set they're injection molded. These are the rollers for the top triangle for holding the timing belts. As you can see, these are not the normal so these are not the normal ball bearings, two of them. Instead, they are spools with an integrated tiny little ball bearing inside, which I think is very good. The gears, 20 teeth each for the stepper motors. Here is the extruder. The extruder, as I told you already, is a version of a E3D extruder. And this is the entirely metal part to hold the extruder. Two cooling fans, one for the extruder and one for the just laid down filament. And this is the U-mount for the extruder and the plate. So the delta arms go on these points. This is also metal, aluminum CNC machined. So the whole extruder is metal except for the fan housings. So this should allow it to work at quite high temperatures. This is the only 3D printer part, the 3D printed part in the kit. This is the nozzle for guiding air from the fan that should cool the filament. And this is the only part in the kit which is 3D printed. The display, you'll see all these parts as I assemble the printer. Bracket for holding the display, also metal, aluminum, and spacers for attaching the display. This is the circuit board. I'll give you a close-up now. Most of the assembly process I will shoot as a time-lapse video, and I will slow it down to a normal speed like this only when there is something interesting or when I deviate from the user manual instructions. Otherwise it will be a time-lapse video with 2 frames per second. So if it takes me 12 hours to assemble this printer, you should have about an hour of video to watch. Hopefully less. The kit has heat sinks for the stepper motor drivers. I'll put this back in the anti-static. SD card, which should have all the files needed, but all of this can be downloaded from the internet. By default they are using a Marlin firmware. I intend to try to make this work with a Repetier firmware, since it is arguably better for Delta printers. It has a lower CPU load. These are the end stop mounts. 3 hex keys. As you see, many of the bags are custom made for them. Anycubic 3D printer accessories. And a bracket for the PC board. This is looks like a laser cut acrylic. In here, let me focus. In here, screws. Many of them. All of the screws are marked with the part number C02 M3x20, and the instructions always mention these numbers when they tell you what kind of screws you should use for the particular setup. So let's look at the rest of the parts in the kit. This pile here is things I ordered separately, mostly. This is in the kit, the timing belt. You're intended to cut it yourself, and there is some springs to set the belt tension, which I think are not good, not a good idea, because they will allow flexibility in the belts. The belt should be tight without being flexible. Wire wrap for arranging the parts to the extruder. These are optical end stops. They were not part of the kit. I bought them separately. Initially I'll probably assemble it with the mechanical end stops, and I'll print mounts for the optical ones later on. One more optical end stop. They were sold in sets of 5 for whatever reason. Pololu drivers, stepper motor drivers with the TI chip. As an alternative, I want to try and see which version works better. So this I also bought separately. A tiny amount of PLA test filament. However, the kit does come with 1 kilogram of PLA, color of your choice, another optical end stop, another driver. And these are the mounts for the bed. They're just brackets. Also injection molded, not 3D printer. USB cable. Next. This is the main motion part of the kit. So, the glass bed, the linear slides. These are the top mounts on the delta arms. These mount on here on the cartridges for the linear slides. And the 20 by 20 extrusions, as well as, just a second, the extrusions, as well as the diagonal arms. They're pre-assembled. They use a ball joint, which seems pretty decent quality. Doesn't seem like it has a lot of play in it, but we'll see. Very critical part for a Delta printer is that all these diagonal arms should be exactly the same length, to a very, very high tolerance, a low tolerance, because any difference in the length of these will manifest as hard to or impossible to compensate distortions in the print. And the last piece which is in here, these are the parts for the extruder. As I already told you, they are all metal, which is very good. Looks like CNC machined aluminum and maybe a steel plate here. You will see as I assemble the set. I will stop the video now for a while and start taking the parts out and assembling them. As I told you, from now on the video will be time-lapse with 2 frames per second, so we will see very fast motion, and I will pause only for interesting parts. An important point here, all the extrusions are very well packed with a sticky type of polyethylene on top of them, but there is a lot of metal shavings from cutting them stuck into it. It's very important that none of these metal shavings should go into the extruder because they can clog it. So keep the work area clean, and once you have unpacked all these extrusions, make sure you remove all the tiny pieces of aluminum shavings off of them. I don't know if I'll be able to show you inside here. The extrusions are very good quality, very cleanly cut. There are practically no burrs to clean, and they are black anodized. Very nice. So back to time-lapse mode. So, 2 important points here. When assembling the top triangle, they suggest that you first attach the corners to the extrusions, make the triangle, and only then install the rollers for the timing belt. However, I think it's more convenient to install the rollers first and then assemble the triangle. Another point, these injection molded, I think, ABS parts are pretty good, but not perfect. There are quite a few of burrs in here, like this one, so I'm gonna clean them up before assembling the printer. So the user manual was right. You cannot put this screw in here, and it would be, it's possible to slip it in, but it would be almost impossible to tighten it once the roller is in place. That's why the rollers should be assembled after the triangle is made. So you'll have to take them off. There was a good reason for this. Back to time-lapse mode. The bottom extrusions are much better injection molded than the top ones, and here is a nice touch. The slot for the extrusion has a flange at the bottom, so it actually bottoms out and you cannot push through the extrusion, which makes for a very nice touch because you just drop it in here and it is fixed. And here is another funny part, actual CE mark on a label at the bottom. So the two triangles, the bottom and top one, are ready. You might have noticed in the time-lapse video that I measured many times from the center of the side of the triangle to the corner. It's critical that this assembly is very symmetric, and in my case they're measuring exactly 25.7 centimeters or 257 millimeters, plus minus half a millimeter, which I think is close enough. And also both should be extremely symmetrical to each other. And it may seem like this is not a very precise way to compare them, but in fact, by eye and by feel, you can sense very small differences in geometry. And this looks pretty good. They're almost exactly the same. These screws here, according to the manual later on, are intended to be completely tightened so that the extrusion, the vertical extrusion which will hold the top frame, is flush with the top surface of the top triangle. However, this is not right. Many other Kossel assembly guides mention that the purpose of these screws is, apart from leveling the top triangle, also in order to tighten the belts. So what will happen is I will leave them just barely catching the nut on the bottom. Here it is. And then the top extrusion will be about 5 millimeters above the surface of this triangle. And then I will assemble the belts as tight as I can. And then using these screws, I will both tighten the belts and make the distance between the top and bottom triangle exactly the same in all three corners. So this is the purpose of these screws. On the rollers, they're really nice bearings. However, one is turning very, very tight. It's possible that it will start going smoother once it's worked in, but I will consider leaving this nut a little bit loose to allow it to turn very smoothly. I think this will not be a problem for the stepper motor. It's not very hard to turn, but still, this turns the easiest. This is a bit harder, and this actually has a grinding feeling to it when you turn it. However, I don't think this will be a problem. So, back to the next step, which is putting the stepper motors in the bottom triangle. You need to assemble the gears on the motor and then put the motor inside. And another point here where I intend to deviate from the user manual. According to this manual, the motor should be assembled pointing up, like this. However, in my opinion, this is not a very good idea, since there will be very little space left for the cable to go out and down, because the bed will be here, also heated bed potentially. And in many other Kossel assembly guides, I've seen the instructions saying that you should assemble the motors with the connector pointing to the side. So this is what I'll do. Hopefully, I'll not find out later that there was a good reason for the motor pointing up. Let's see. note on the hot end, or really the whole extrusion head. As I mentioned in the beginning, it's completely made of metal, which is very good. This is, I think, steel, cut and bent. You noticed I plugged the top of the extruder with this piece of plastic bag, because if any dirt shavings, metal shavings get in there, the nozzle will clog and I'll have a big trouble after that. So, very good design on the extruder. As you see, the E3D type hot end with the heatsink attached in here. I don't know if it's possible to see at all, with this U-shaped piece which is screwed to the top with these 4 screws. And then the only, as I mentioned before, plastic 3D printed part in this kit, this air guide which blows directly and at the extruded line. You can see here that it's barely above the level of the extrusion. As usual for 3D printed parts, you noticed probably in the time-lapse section, it took me a long time to align this with the aluminum plate. However, extremely well printed. The dimensions are correct, the screw holes matched up perfectly. They were just a bit undersized, which is very normal for 3D printed parts. But otherwise, the Anycubic guys obviously know how to 3D print. And the last thing which needs to be placed on here, the cooling fans. There are 2 of them. One, which is a true fan, goes on here and cools the heatsink on the extruder. And the other one, which is a turbine type, sucking air from in here and pushing it out of here. It will go on here. I don't know if you can see probably here. Yes, you see this gap? This is the air coming out of the fan, going in here and out of the part cooling nozzle. Very nice design. I like this. Let's see how it will work in practice, but just assembling it, I see that it's very good. This can still move here because I haven't tightened these 4 screws, and the manual mentioned this in order to be able to work comfortably. The nozzle looks very well centered. When I turn it, it doesn't wobble. And overall, the extruder design and the whole printing head looks pretty good. There is something I should mention here. There is a mod which Anycubic posted on their Google Drive. There will be 2 copper spacers here to make the arms go a little bit wider than they would like this, which I think will allow them ability to move at steeper angles and print to the corners of the printing bed. I didn't have these spacers in the kit I received, but I contacted them and they immediately said they will send it to me with a next order I made for some thermistors for the heating bed. So their customer service is very good so far. They respond quickly, in very good English, and they're knowledgeable. So back to the time-lapse mode. here. As I mentioned in the beginning, these are the diagonal rods with the bow joints at the ends. It's very critical that they all should be the same length, and I was worried how precise they were because they are glued in the factory. These are carbon fiber rods with some kind of bow joint, which is metal, probably aluminum, and they should be all exactly the same length. The bow joints are glued into the carbon fiber rods with something which looks like epoxy, and I put 2 hex screws through all of them, and I'm just tilting them as much as possible and checking if all of them touch the hex key at the same time. And it seems they're all pretty good. When they're all at the extreme end, none of them can wiggle freely, which means they're pretty good tolerance lengthwise to each other. Every time I wiggle this assembly in any direction, it sits perfectly symmetrical. And this is the proper way to do them. I presume Anycubic are using some kind of jig to glue them in place. So my worry was unfounded. They did a pretty good job. So the step I'm going to do now is attaching the diagonal rods to the carriages, or I guess belt tensioners, because the timing belt will come through here, and each rod will be attached like this to the belt tensioner on one side and to the printing head on the other side. And again, they made a change where they have a copper spacer, very thin M31 in here, about 5 millimeters long as far as I can see from the pictures. And the reason they did it is because you can see that when, or maybe you cannot see, so I'll come closer. And the problem is that when the bow joint is on here, there is very little possibility of it to move around, which means the angle between the arm and the carriage can change too little. And this means that towards the extreme ends of the printing bed, the body of the bow joint will hit the plastic. So this is the reason they've introduced a spacer in here. I don't have appropriate ones to use right now, but they will send me some and then I'll modify the printer. So here is the first real problem in assembling this printer. On the cartridges, which should be attached with these screws, in 4 of the holes the screws go in just fine, but in 3 of them, but the 4th one is injection molded so tight that it's impossible to get the screw in, so I'll have to open it up with a drill bit. This is the first, let's say, serious problem I've met so far with assembling this printer. Everything else was going very smoothly and nicely. And this is the first time something didn't go as planned or as designed. I could take out my drill, but I think this is soft enough plastic that I'll be able to open it up by hand. Almost ready. I'm using a wood drill bit which has a flat end to allow for a flat bottom. And I'm almost to the bottom of the hole. Let's do time-lapse again. So here is an interesting point. The aluminum extrusion allows the linear guide to move quite a bit, since the screws are much smaller diameter than the slit in the extrusion. So I need to find some way to fix this, otherwise when tightening the screw I have no way to guarantee that this will be vertical and parallel to the extrusion, which will allow it to move a lot and will distort the geometry. So I've made this quick and dirty template which will go into the hole of the extrusion and catch the sides of the into the holes of the guide rail and catch the sides of the extrusion, and this way it will fix it and will not allow it to move. And I'll attach it at the top, tighten one screw, attach it at the bottom, tighten another screw, and then check a few points along the way. Here's an interesting point. The end stop switches, which are mounted here on this, you cannot see them, but up here on these end stop mounts, they have, here it is, this is where the switch goes. There were two problems with them. First of all, the M2.5 screw, which should go into the switch, is too tight and won't actually go in unless you drill it through. But I did that was easy. And the other thing, the head of the screw, when it's put inside the switch like this, it hits the belt, since it's sitting like this here, and the screw actually hits the belt just barely, but in my opinion enough to wear it down over time. So what I ended up doing is I shaved off these here areas on the switch. You can see on this one I've already shaved it off on this side, and I still haven't done it on this side. And when you do it on both sides, then the screws don't hit the switch anymore. So that's it. So the basic mechanical structure of the printer is ready. The linear slides are installed together with the diagonal rods. The print head is assembled, and the belt tensioning. An interesting point here. I split the belt very carefully in exactly 3 pieces up to 1 tooth length, so they're exactly the same length. And after I have split them, I did the following. I measured the section of the belt which stretches beyond the pulley, and made it exactly the same on both belts. And I measured the section of the belt above the pulley in here, and I made it exactly the same on all 3 belts. And I tensioned them as much as I could without using these springs here, which they give as an advice of how to adjust the belt tension, which I think are not a good idea, because as I mentioned, if you put these springs on the belt, they make a flexible section which, when the slides are accelerating up or down, allows the belt to stretch a little bit, which makes it more flexible. And you want the guide system of the printer to be as rigid as possible. And for the motion system, I've already noticed what I mentioned in the beginning of this video, that the head motion is limited, because when you push it, for example, to this side, the bow joint touches the plastic right here or right here, and it's impossible to move further in that direction, same way in this direction. And this limits the amount of travel the head can do around the print plate. So the way the Anycubic guys have solved this problem is with a mod, which involves inserting these spacers. I'll show you. Inserting these spacers here, which are very thin copper tubes, to push the ball joint a little bit further from the plastic, so that when it twists, it won't hit the plastic. I still haven't received the parts. Anycubic will send them to me, because they were introduced on November 22nd, after they had already shipped the printer to me. However, I found a temporary solution. I found this piece of pipe with internal diameter 3 millimeters, external diameter 4 millimeters, which is perfect. And on a lathe, I'll have 5 millimeter sections cut out of it, and I'll use these as spacers. So this will work. And now the next step in the assembly is the extruder. Here it is. All metal, as I've already mentioned a couple of times. And then we move on to the electronics. Here is a spot where I will deviate from the manual. According to the manual, close up, you should assemble the board in here and then treat the X, Y and Z back here axis as the 3 columns. However, I think it makes more sense to treat the panel as the front and then name the columns X, Y and Z. Or for example, like they're called alpha, beta and gamma in firmwares like Smoothieware. Makes more sense to me because the display is logically the front of the printer, which you are looking at most of the time. So I will mount the board, which goes onto this plate like this. I think I'll mount the board here to the side, maybe to the other side here, since the extruder motor, the connector comes down here, and I've also routed the wires from the printing head to come on this side as well as the Bowden tube. So the wires, I'm showing you something which you don't see right now. Just a second, I'm sorry. So I've routed the wires from the extruder to come out on this side, as well as the connector for the wires for the printing head, thermistor, heater and the 2 fans to come out on this side. I've passed the Bowden tube, which you can see right here, and a little bit up. I've routed the Bowden tube to pass on this side of the column I'll call Z, and the connector on the extruder motor is on this side. So I will mount the board on this side of the printer as well. This will be my front, so alpha, beta, gamma or X, Y, Z axis. Back to the time-lapse mode. So here is a small detail about mounting the board to the plate. The suggestion in the manual is to use 3 screws and 3 nuts back here to do this. However, I think there is a better way. The board goes on here, and it will be a bit hard to show you this, but the solder joints need spacing, not to touch the acrylic here. So I've decided that I'll put 2 nuts onto the screws first. Here I'll do the 3rd on camera, like this. I do have 3 extra M3 nuts in the set. Perhaps they were spares, perhaps they were intended for this, but it's not mentioned in the user manual. And if it turns out they were needed for something else, I can always buy more. So I've placed the 3 screws here, with a nut on it. And now when I slide the board on, there should be a very nice spacing. However, it doesn't work so easily every time. So anyway, back to time-lapse mode. You see me mounting the rest of the board and into the printer. Here is the part I wanted to show. Nuts make for a nice spacer that holds the board right here, and on the other side right here. So I think I'll leave it mounted like that. Now it turns out it doesn't work with extra nut spacers, because in that case the board will not be able to fit between the extrusions with an extra nut here, unfortunately. Otherwise it was a pretty decent arrangement, but when I put a nut on here, the whole stack becomes way too thick to fit in the space between the two extrusions, and I don't really want to force it. So I removed the spacer nuts that I placed just a few minutes ago. here is a close look at what I've achieved as far as cable management goes. X, Y and Z motors. X goes underneath the board to the connector out here. Y and Z folded in here. Extruder motor cable goes through here on the outside for a bit, comes in. I'll try to show you in detail. Comes in through here, and then I'll turn the printer around. Comes out of here, down the slide, into the extruder motor, and stops. Not so hard at all. Z, Y and X, and the Y and X you can see here I've looped them through these slits in the injection molded part, and down there in the dark, if I turn the printer again you'll be able to see it. Down here in the dark you can see the cable display, and of course the cables for the display going to the board. That should be all as far as assembly of the electronics. So mechanically the printer is ready. All I have left to do is connect the two cooling fans, the heater and the thermistor for the hot end, as well as install the bed, and then we can start with the electronics. A pleasant surprise, in the instructions it mentioned that I should install the firmware myself. However, when I give power to the printer, I think you'll be able to see, yes, I get a typical Marlin kind of user interface. Here it is, which means that I have a preloaded firmware. I can change the feed rate, nothing else, as it says min temp, which is the error message for the thermistor not being connected. However, since I intend to install Repetier firmware on this printer, I will override this firmware. However, I will use it initially to see if my connections are okay, whether the end stops work, and so on. So I will connect the two fans and the thermistor. I'm not going to connect the hot end for now, and I'll try just whether the 4 axes and the end stops work. Another trick I did here, when the extruder doesn't have filament inside, the gear is touching the hobbed bolt, which is not a good idea, because if I start turning the extruder, they'll grind against each other. So I use this bottle here, which fits very nicely and allows the axis of the extruder to spin freely. Just as a precaution, because I don't want to put filament in there yet. I want to adjust PID regulation and so on before I'm ready to put firmware. So now into time-lapse mode. is the printer with the bed attached, electronics. You saw me wrapping the cables going to the extruder, attaching them with a cable tie down here. The extruder back there is still held open. I spent quite a bit of time making Repetier firmware work on here, but I'm not going to bother you with this because it is just sitting on the computer, and I will put a version of my Repetier firmware on GitHub for whoever is interested to download. So now I've made sure all the columns are exactly the same height. I've made sure that when the head is homed, the distance between here and the bottom is the same. So what I can do now, see currently the motors are off. I'll home the head. And now comes the interesting part. We should move down until the head barely touches the surface. Record that number and change the printer height in the firmware. Currently I've set it to 30 centimeters for 300 millimeters, but it will probably be a bit more. I'm moving by 0.01 now. And here is the sheet, slightly dragging under the extruder, which is the perfect bed level. You see my Z height is 3.25 millimeters, which means that I don't have 300 millimeters, but I have 296.75 millimeters of height. So I'll change the firmware now and we'll try again. So I'm uploading the firmware right now, and once that's done, we'll try again. Okay, it's almost finished uploading. And that's why adjusting the firmware is so boring. It takes a long time without nothing happening. Okay, it's done. I connect to the printer, home the 3 axes, and start down. And here my z-axis is at 0, and I didn't quite succeed to touch the piece of paper. Yes, it drags, but less than I would have liked. So what I'll do is I'll increase it a little bit, the printer height. Okay, height increased once again. Connect to the printer, home it. To make sure all the So 0 doesn't allow me to move the piece of paper at all. 0.1 allows me to barely move it. I know this is not precise enough, but I try to measure the thickness of this paper with the caliper. It's 0.1, which means bed leveling is pretty much spot on. See, now I'm at 0, cannot put anything in there. 0.1, piece of paper goes in slightly dragging. I think that's as good as it can get. And my height is 296.85 millimeters. So now comes the hard part, to level the printing platform in the three corners next to the columns, and make sure the diagonal rod size and printer diameter or printer radius are correct, because the diagonal rod length influences the scale of the things you print. If it's too long, things will print shorter than they should. If it's too short, things will print larger than they should. And the printer radius influences whether, when you're at 0 at the center of the bed, when you go towards the edges, the shape can go up, the head, or when you are at 0 at the center of the bed, it can go down towards the edges and actually go into the bed and hit it. So this is a little bit tedious, and I will not shoot a video of this. And here is the first ever print with this printer, which is almost complete. And that's it. The printer is ready. And doesn't it look cool? With transparent glass. And the first print on top. So, I hope you enjoyed this assembly video. Next I'll give you a short summary. So you can watch the printer print this test while I will give you a short impression from assembling it. Overall, the Anycubic linear Kossel is a great kit for assembling a Delta printer. Big advantages: all metal extruder, all metal printing head, cooling fan for the printing head, cooling fan for the part. The corners, which in a Kossel are usually 3D printer, here are injection molded plastic, looks like ABS. The plate carrying the display is a metal one as well. I will show you right now. I'm talking about this one. Also, the board, which is called Tri-Gorilla, and it is Arduino Mega combination with Ramps 1.4, works pretty well as far as I have seen so far. The firmware that was loaded on there by default was some kind of Marlin, which was completely non-functional. With quite a bit of digging and configuring, I've made Repetier host work perfectly on this board, controlling both fans, the one cooling the extruder here and the one on the other side which cools the printed part. The cable management is very convenient with this black cable wrap. The extruder works pretty well so far. This is just my second print and it's coming out amazingly good. I'm just surprised considering this is my first Delta printer. However, I've spent around 7 hours overall configuring the firmware and calibrating it. Now I will put the firmware on GitHub so it will be easier for anyone who wants to follow and use Repetier firmware on this printer. The advantage of using Repetier is that it has much lower CPU load compared to Marlin, so it's a better firmware for a Delta printer, which in general has more complex math. Other impressions for the printer: the linear slides are pretty good. The extrusions are very high quality, black anodized, and apart from the few modifications that I had to do, which I've mentioned during the assembly, the process was very smooth. The extension spacers, which Anycubic will send me to add here, are extremely important, because as it is, the printable area is a circle with a diameter of 100 millimeters, which is really a waste considering this glass bed is 200 millimeters in diameter. So the printable area is 10 centimeters when we have a 20 centimeter glass bed. I have not mounted the heated bed, even though I've bought one, as well as I haven't tried installing the optical end stops, but I'll have to design and print mounts for them. What else? The default current set for the Polo Loose sounded so good, you can hear the printer working, but I have not actually verified the current setting, but this is something I will do. The hot end heats up pretty fast, in less than 2 minutes, from room temperature to 200 degrees. And in fact, this was a great experience. The printer worked very well, and it was a surprisingly good kit for the price. So I'll let you watch this print finish, and thanks for watching. So here is a funny thing, this part did not stick to the bed. At some point it detached, and now the printer is printing in the air, trying to extrude something which doesn't exist. However, the part printed pretty well. Of course I'm going to cancel the print, but it was very interesting. experience. Next time I print one of these, I will have to place some glue on the bed. But overall, great job. The printer did amazingly well. I'll try to show you a close-up of this very hard to print nicely part. Of course, the stuff on top here is just the layer which was already messed up, but the rest is very, very good. No stringing, no nothing. It is a bit brighter light. So you can see the details. If I clean up the filament which was deposited after the part detached, you will see how clean it actually is. This is the spot where it actually detached itself. Very, very little stringing and very little problems with it. Very nice. So, that's all. We'll play with the printer another time again. It's a plastic filament. This was the 3D Benchy, printed it in about an hour.
Foxy.
The